Hello viewers, welcome to UN College Digital class. In today's session, I am going to discuss about parsing. In the previous classes, already I have discussed about lexical analyzer, syntax analyzer, and in this session, I am going to discuss in detail about parsing, which is performed in syntax analysis phase. We will discuss the types of parsing, what are the different approaches of parsing, etc. Let's start in detail. In the previous classes of compiler designing, we have already discussed about syntax analysis phase, and we know that in syntax analysis phase, number of operation, number of processes are implemented. And one of the very interesting concept which is used in syntax analysis phase, that is parsing. But before going to discuss on parsing, first we must understand what is the meaning of parse tree, because the output which is generated by the second phase, and that is syntax analysis phase, is parse tree, and the parser is responsible to generate the parse tree. So first we will discuss on parse tree. Actually parse tree is nothing, it is just like a tree like structure, but it is the graphical representation of symbol. Which symbol? The input which is inputted by the user or the programmer, and the symbols can be terminals and non-terminals. We know that what is the meaning of terminals and what is the meaning of non-terminal. Always we have to remember the concept about terminal and non-terminal. Non-terminal which can be expanded, terminal which cannot be expanded. In parsing, the string is derived using the start symbol, and the start symbol is represented by using capital S. Parse tree follows precedence of operators. Okay, we know what is the meaning of precedence of operator. When we are doing any expression, calculation, any sort of calculation, at that time, if in our expression, if in our statement multiple operations are there, then it follows precedence of operator. It means that the operator which having the highest precedence or highest priority, that will be executed first in this way. Okay, the same rule is followed here, and for that reason the deepest subtree traversed first, and so the operator in the parent node has less precedence over the operator in the subtree. Now we will discuss some points, or we may say that some concepts on the basis of which parse tree is based. Okay, now we will discuss those points. First one is, all leaf node have to be terminal, obviously, because parsing start from the start symbol, which is a non-terminal, which will be expanded, and it will reach at which place? Obviously at the leaf node, and that is the destination. Now we will discuss about the second point. Okay, all interior nodes have to be non-terminal. Why? Obviously it is obvious that because only the non-terminal can be expanded, terminals cannot be expanded. That's why the interior node which is going to be expanded further must be non-terminal. And the third point is that in-order traversal gives original input string. We know that there are number of ways of traversing a tree, and here we are using in-order traversal. Now we will discuss the different categories of parsing, and that is top-down parsing, and the second one is bottom-up parsing. Here I have represented the two categories of parsing in a pictorial way. Then next one is, we will discuss about top-down parsing. It is very simple one. Top-down parsing is nothing, it is the process of constructing the parse tree which starts from the root and goes down to the leaf in this way. Okay, it starts from the root and it implement number of production rule, then gradually it moves towards the leaf. Okay, it constructs the parse tree from the grammar which is free from ambiguity. In the previous class of compiler designing, already we have discussed what is the meaning of ambiguity in grammar. Okay, if you have not gone through that video, then please go through that, so that you will be clear what is ambiguity and how we can convert one ambiguous grammar to unambiguous. Then the next point is that Top-down parser uses leftmost derivation. Already we have discussed about leftmost derivation and rightmost derivation in the previous video. And the next point which is used in case of top-down parsing is that it allows a grammar which is free from left factoring. Now here I have represented one pictorial representation of how the top-down parsing perform the operation. It starts from the start symbol, means the input string, and it is gradually goes by implementing number of if-else condition, by implementing the different production rule. Gradually it grows towards the leaf, which are all the terminal. Okay. Then the one of the very interesting concept, that is backtracking, and already in my designing analysis algorithm class I have discussed about backtracking. Backtracking is a very interesting concept which implements brute force technique. What is the meaning of backtracking? If we will discuss in a simpler way, okay, backtracking is nothing. For example, suppose you are doing a task and the task consists of number of subtasks, and when you are doing the task, doing the subtasks one by one. In this way, suppose let assume that at a particular point you realize that there is no valid output. Okay, you are not getting valid output. At that time, what you will do? You will just go back and you will choose some alternative way. Exactly what is happening in backtracking, and that backtracking is used in top-down parsing. Then top-down parser starts from the root node, which is the start symbol, we know that, and match the input string against the production rule to replace them if any matching is there. Whenever a non-terminal is expanded, the first rule is implemented, obviously, and that is compared with the input symbol. If matching occurs, then it is okay. But if the matching does not occur, then the second alternative rule is used and comparison is going on. Okay. If matching occur for at least one alternative, then the input string is parsed successfully. Now I am going to explain the top-down parsing by using a very simple example so that your concept will be clear. Okay. In this example, let the grammar, okay, let the production rules are S implies RXT, S implies RZD, X implies OA, X implies EA, Z implies AI, and let the input string is READ. Okay. Here you can see that number of input symbols are in small letter, number of, now in case of production rule, okay, number of symbols are in small letter, number of symbols are in capital letter. All those which are in capital letter, those are non-terminal, and all those which are in small letter are terminal. At the first step, what parser will do? Parser will start from the using the first production rule, that is S implies RXT, and by implementing RXT, by applying RXT, the tree is looking like this. And here what happened? We have got our the first leftmost letter input, that is R, which is matched letter. Okay, so we will move to the second phase, and in the second phase, now what the parser will do? Now the parser will move to the next input letter, that is E, and to match or to get E, parser will expand X with the next production rule, that is OA, and now the tree will be looked like this. S, which is implementing RXT, then X again implementing OA, but unfortunately we have not got our matched input, because if you will take this string, then the output will be ROAD, but we don't need this one, we need READ. And for that reason, here what parser will do? Now parser will do backtracking. Now parser will backtrack and we will get such type of output. Okay, actually here backtracking is nothing, it is just returning back to the previous section. Okay, and then what the next step? And then what parser will do? Parser will use the next rule, x implies EA, and the tree will be looked like this, and here we have got our input string, that is READ. In this way the string is accepted. Here I am going to explain the same example once again. In one slide I am going to show you all the different type of subtree. Okay. At the first step we are implementing s implies rxt and the tree will be looked like this. At the second stage we are going to implement x implies OA and the tree will be looked like this, and here we have not got our matched input, that's why backtracking will be performed. And at the final stage and at the fourth stage we are implementing x implies EA and the tree will be looked like this, and here we got our accepted string, that is READ. Now we are going to discuss about bottom-up parser, which is just opposite of top-down parser. Bottom-up parser, it is the parser which generates the parse tree for the given input string with the help of the grammar production by compressing the non-terminal. What is the meaning of this by compressing the non-terminal? The meaning is that here the non-terminals are compressed, non-terminals are used and the terminals are derivated. But in case of top-down approach, what we are doing? We are taking the non-terminal and we are expanding towards the terminal. This is just the opposite of top-down approach. It starts from the non-terminal and ends on the start symbol. It uses just reverse to the rightmost derivation. Now I have used one pictorial representation how the bottom-up parsing is doing the operation. Here it is clearly visible that the input symbols are taken and gradually the production rules are implemented, and at the end we are generating the start symbol. Bottom-up parser is classified into following types: shift reducing parsing, operator precedence parsing, and LR parsing. In case of shift reducing parsing, the parser takes the given input string and builds a parse tree. It starts from the bottom at the leaves and gradually it grows towards the top. Okay. Then we will talk about the operator precedence parser. Actually, operator precedence parser is nothing. It is the parser which follows the operator precedence grammar. Okay. But first of all, we must know what is the meaning of operator precedence grammar. Operator precedence grammar is based on following condition. One condition is that there exists no production rule which contains one empty symbol on its RHS, right hand side. And the second condition is that there exists no production rule which contains two non-terminals adjacent to each other on its right hand side. Actually, all of us know about precedence of operator. Exactly the same operation, the same process is used here, and the grammar is based on the same concept of priority of operator. When two operators are having same priority, associativity concept is implemented and the grammar is called as precedence and the grammar is called as operator precedence grammar, and the parser which follows operator precedence grammar is termed as operator precedence parser. Now we will talk about LR parser. Actually, LR parser is categorized into four categories. Those are LR0, SLR1, LALR1, CLR1. In the next class, we will discuss more about operator precedence, shift reducing, and LR parser. Now I have taken one example so that you will be clear how the bottom-up parser is working. In this example, I have used production rules. Those are S implies AABE, A implies ABC, A implies V, B implies T, and let the input is ABBCDE. Okay. Now in this example you can see that some symbols are in small letter, some symbols are in capital letter, and you know about terminal and non-terminal, so there is no need of explanation. Now we will start. Okay. First of all, we will use the production rule A implies B. Then we will use the next production rule A implies ABC. And then after this expansion, we will use the production rule B implies D. And finally, we will use the production rule S implies AABE. Okay, in this way. But here, I am going to explain this by using pictorial representation so that you will be very clear. I have mentioned the production rule and the input. Let's start. At the first step, what we are doing? We are using A implies B. Okay. And in this way, we got the output string A, B, C, D, E. And then we are moving to the next production rule, and now we are using the production rule A implies A, B, C, and in this way we got the output A, D, E. And next we are using the production rule here B implies D, and in this way we are getting the output A, B, E. And finally, we are using the production rule S, and in this way we are getting AABE. Okay. In this way we have got the input string derivated, and in this way the bottom-up parser is working. Now we will talk about one very interesting topic, that is the differences in between top-down parser and bottom-up parser. Let's start. The first difference is, in case of top-down parser, the strategy is first looks at the highest level of the parse tree and gradually works down the parse tree by using the rules of grammar. Okay, but it is just the opposite in case of bottom-up parsing. In case of bottom-up parsing, the strategy is first look at the lowest level of the parse tree and work off the parse tree by using the rules of grammar. Then we are going to discuss the second difference. In top-down parsing, we start parsing from top or start symbol, but in case of bottom-up parsing, we start parsing from bottom or leaf node. Then the next one, top-down parsing techniques uses leftmost derivation, whereas bottom-up parsing techniques use rightmost derivation. And in the previous class already I have discussed about what is leftmost derivation and what is rightmost derivation. Then next one is, in top-down parsing, the main decision is to select what production rule is to use in order to construct the string. But in case of bottom-up, the main decision is to select when to use a production rule to reduce the string to get the starting symbol. Actually, both top-down approach and bottom-up approach are working very effectively, but it depends when the programmer will use top-down approach and when the programmer will use bottom-up approach.
I hope you have got some basic idea about top-down parsing and bottom-up parsing in this session. In details, we will discuss in the next session about shift reducing parsing and operator precedence parsing. If you have any doubt in this session, then please write to me in the comment box so that I can clear your doubt. Thank you so much for watching. Have a great time.